All right, good morning, guys. Today we're going to be covering 10.6, volume of spheres and density. Our learning target today is I can use mass, volume, and density to determine the population density of areas. Let's go ahead and start right away with the volume of a sphere. So, volume of a sphere is going to be equal to 4/3 pi times the radius cubed. So, of course, r is going to stand for the radius here. And we notice that we're dealing with cubed units instead of squared units. So that's a big difference from surface area and from just the area of a circle. Now, an easy way to remember that is that there's a 3 that you're dividing by for 4/3. So it's going to be raised to the third power as well. This is the only time that you're going to be seeing a fraction for circles like this. And it's the only fraction that's different from 1/3. So just keep that in mind. Now, for an example, we want to find the radius of a sphere. We want to find the volume of a sphere with the radius of 3 meters. So I'm just going to go ahead and take that 3, and I'm going to plug it in for r, the radius. That will give me the volume is equal to 4/3 times pi times 3 cubed, or to the third power. Well, 3 times 3 is 9, times 3 is 27. So we have 4/3 times pi times 27. If I multiply 4 times 27 pi, that will give me 108 pi over 3. And then lastly, 3 will go into 108 36 times. So our final answer is 36 pi meters cubed. That will be the volume of a sphere with a radius of 3 meters. Next up, if a sphere has a volume of 288 pi feet cubed, what is its radius? Now, before I actually do this one, I just want to show you guys real quick how to do 3 cubed on your calculator. If you go to a TI-83 or TI-84, this is pretty much an emulator of that. To raise it to the third power, I'm just going to do 3, and then we have this caret button here. It looks like an upward-facing arrow. It's shaded in right now. If you click on this will allow you to put in any exponent. So if I click on it, you see that it raises to an exponent in our little bar up top. And then I can put in any exponent there. But we're raising it to the third power, so I can just do 3. When I hit enter, you can see that it gives us 27. From there, I multiply by 4/3, so I just do times 4, and you can see that that gives me my answer times 4. And then I divide that answer by 3. That's the same as multiplying by 4/3. And as we can see, we get 36, which is our exact same answer as over in our presentation. So that's how you can enter it very quickly in on your calculator if you'd like. Now, our next one. They say the sphere has a volume of 288 pi feet cubed. We want to know the radius. So I'm going to go ahead and take 288 pi, and I'm going to plug it in for the volume, V. So I have 288 pi equals 4/3 times r cubed. The next thing I'm going to do is I'm going to get rid of this 4/3. To do that, I need to multiply both sides of my equation by the reciprocal. So if I flip this fraction over, I have my reciprocal as 3/4. 288 times 3/4 will give us 216 pi. So we have 216 pi equals pi r cubed. From here, I need to get rid of the pi. So I divide both sides by pi, and the pi's will just cancel, leaving us with 216 equals r cubed. Lastly, we need to get r by itself, so I need to get rid of this cubed. Now, a good way to think about this is how would I get rid of a square in this scenario? Well, I'd take the square root, because the opposite of squaring something is to take the square root. Is there something for cubed powers like that? Well, yes, it's called the cubed root. And it's the same exact concept. If cubing something is multiplying the number by itself 3 times, taking the cube root of something is the exact same thing as taking the square root, except we're doing it 3 times. So essentially, we need 3 pairs of numbers that are the same in order to take it out of the cube root. Now, to do that on your calculator, you're just going to go ahead and hit this math button up here. It says math, it's on the left side of your calculator. When you do that, it gives you a whole list of things. If I look down this list, number 4 has the cube root. You see that 3 right in front of the square root sign. That means cubed root. The one right below it, number 5, that has an x right above the square root sign. Number 5 says that I can plug in any value for x, and that would be the root that I would be taking. So if I plugged in a 6, that'd be the 6th root. or so on and so forth. But if I want the cube root, I'm just going to go ahead and do number 4, and then I'll put in whatever number I'm taking the cube root of. Well, we're taking the cube root of 216, because what I do to one side, I must do to the other. That will give us 6. So if I go back over here, I take the cube root of both sides. 6 times itself 3 times will equal 216. Therefore, our radius is 6 feet. All right, let's go ahead and try out, next up, the hemisphere. So for a hemisphere, it's just half of a sphere. So its volume formula should be half of a volume, half of the volume of a sphere. Now, we don't need to worry about the base because it's not surface area that we're dealing with. So it's really just taking half the volume of a sphere. Now, if the volume of a sphere is 4/3 pi r cubed, I just need to multiply that by 1/2. Now, when we're multiplying by fractions, we multiply straight across. So 1 times 4 is 4. 2 times 3 is 6. So we're left with 4/6 times pi r cubed. Of course, I can reduce down 4/6. That can reduce down to 2/3. Therefore, the volume is equal to 2/3 pi r cubed. That is the volume for any hemisphere. And again, it's just the amount of space that a hemisphere takes up. So again, with any radius, we'd be able to plug in and find that volume right away. All right, let's go ahead and try out some examples with hemispheres. We have a hemispherical dome that has a height of 30 meters. Now, if it has a height of 30 meters, that means that its radius is 30 meters. So no matter where it goes, that radius will be 30 within this hemisphere. So if I want to find the total volume enclosed, I'm just going to use the volume of a hemisphere. 2/3 times pi times 30 cubed. If I enter this into my calculator, that will give me 18,000 pi. So the volume of this hemisphere is 18,000 pi meters cubed. Again, 30 times 30 will give me 900. 900 times 30 will give me 27,000. And then 2/3 of 27,000 is 18,000. Next up, find the area of the ground covered by the dome. Let's go ahead and find that on our picture. The area of the ground is this shape right here. And if we look at that shape, that's a circle. So we just need the area of a circle with a radius of 30. So therefore, area is equal to pi times 30 squared. Well, 30 times itself is 900. So therefore, the area is just 900 pi. Next up, we want to find out how much more paint is needed to paint the dome than is needed to paint the floor. Well, if we're painting the dome, think about what that is. If I'm painting the outside of the dome, that's the outside facing area, which would be the surface area. So, and I'm not counting the base here, so I'll go ahead and call that the lateral area for now. So the lateral area for a hemisphere will be 2 pi r squared, because the surface area of a full sphere is 4 pi r squared. So therefore, I just take half of that, and since we're not including the base, I'm not going to include the pi r squared there. So that'll just give me 2 times pi times 30 squared. 30 squared is 900, so I'm essentially just multiplying this answer by 2. So therefore, we have 1,800 pi meters squared. Lastly, we want to find the radius of a dome that would double the ground area. Well, we know that the ground area was 900 pi meters squared. We want to double that. So therefore, I'm going to go ahead and set my volume equal to double 900 pi meters squared, or set it equal to 1,800 pi meters squared. Oh, I'm sorry, I forgot to find the difference in paint that I need. So to find the difference, I'm just going to go ahead and take the surface area of the hemisphere and subtract it from the area of the circle of the base. That will just give me 1,800 pi minus 900 pi, which of course is just 900 pi meters squared. Now again, for letter D, I'm just going to take double the area of my base, 900 pi, and doubling that would give me 1,800 pi, and that's my volume. 1,800 pi is equal to pi r squared. And again, we're doubling the ground area. Since the ground area is just a circle, I'm using the area of a circle. From here, I just divide both sides by pi, which will leave me with 1800 equals r squared. If I want to get r by itself, I must take the square root of both sides, which will leave me with r is equal to 30 radical 2. Now, the way that I got 30 rad 2 is I just took 1800 and I broke it down. 900 times 2 is 1800. 900 can be broken down into 30 and 30, because we just saw that 30 squared is 900. Well, if I have a pair of numbers, and since this is a square root, I only need 2 of the numbers to get out. The 30s can leave, the 2 remains. So therefore, the radius is 30 rad 2. All right, next up, let's go ahead and talk a little bit about density. The density of an object is the object's mass per given unit of volume. So density is equal to mass over volume. Now, an easy way to remember this is you can think of it as our school. Mountain Point is over Desert Vista. So that's an easy way for you to remember this. If I plug in variables as d, m, and v, we can go ahead and we can create a couple more equations with this as well, just by manipulating this. But again, this is the most important one, so I'm going to go ahead and put a couple stars next to it, just to make sure that you take note that this is what we actually need. So if I want to solve for the mass, I'm just going to multiply both sides by volume. So mass is equal to density times volume. Further, if I want to get volume by itself, I divide both sides by the density, and volume is equal to mass over density. So these are the 3 equations that we were able to manipulate in order to find mass, density, or volume, as long as we have 2 of the 3. So, with the density, we're going to go ahead and use this information in order to solve for the density of objects. Now keep in mind, this is a chapter on volume. So we're typically going to have to find the volume, and we'll probably be given the mass. Let's go ahead and see an example problem of this. You have 2 types of wood, and you want to see which one is more dense. You have 2 logs, so they're both going to be cylinders, with the following diameters and heights. So the 2 types of wood that we have are Douglas fir, and we have a redwood. The diameter of these 2 logs, I should say, one is 6 centimeters and the other is 8 centimeters. The height of the Douglas fir is 17 centimeters and the height of the redwood is 12. And lastly, they have different masses because they're different types of wood. So our first step is to find the volume. Now, of course, we're going to use the volume of a cylinder because the logs are made of cylinders. So therefore, we have pi r squared, the area of a circle, times the height of our cylinder. So starting with the Douglas fir, we first need the radii, because they give us the diameter. Well, the radius of the Douglas fir would be 3, half of 6, and the radius of the redwood would be 4, half of 8. Starting with the Douglas fir, I'm going to go ahead and plug in the variables for r and h into our formula. We'll have volume is equal to pi times 3 squared times 17. 3 squared is 9. 9 times 17 is 153 pi centimeters cubed. Now that we have the volume of the Douglas fir, let's go ahead and find the volume of the redwood. We're going to use the same equation, except this time I'm plugging 4 in for r and 12 in for h. That will give me pi times 4 squared times 12. 4 squared is 16. 16 times 12 is 192 pi. Therefore, the volume of the redwood is 192 pi centimeters cubed. Now that we have the volumes, we should be able to solve for the density, because density is equal to mass over volume. Starting with the Douglas fir, to find that density, we're going to go ahead and use 254 divided by 153 pi. Now, when you enter this into your calculator, make sure that you have parentheses around the 153 pi. Because if you don't, your calculator will do this wrong, and it'll do 254 divided by 153, and then multiply that by pi. But again, the 153 needs to be multiplied by pi first instead. If you enter that into your calculator, you should get 0.54, I believe? No, 0.53. 0.53 grams per centimeter cubed. We do the same thing with redwood. This time we're going to do 271 grams divided by 192 pi. And And again, make sure that you have your parentheses around the bottom there, 192 pi. And when you enter that into your calculator, you'll get 0.45 grams per centimeter cubed. Now, again, we want to know which one is the more dense log. So looking at this, the Douglas fir has more density per cubic meter, or cubic centimeter, than the redwood does. So therefore, the Douglas fir is more dense. All right, our last topic for today is population density. Population density is used to calculate the density of the amount of people, animals, other things that are all within a certain amount of area, a certain amount of space. This can be used for a variety of different statistics and is used constantly in the real world. So the way that we get population density is it's just going to be the population of whatever you're taking the population of, whether it be animals, humans, aliens, whatever it may be, divided by the area, the amount of space that it takes up. So we have a couple examples here. In Arizona, we have a population of 7.3 million. Now, this may be updated since the census was fairly recently, but as of the last census, we were at 7.3 million people, and the area of Arizona is about 114,000 miles squared. What we want to know is the population density of Arizona. So to do that, we just do our population, 7.3 million, divided by our area, 114,000. Now make sure that you count up your zeros as you do this. That'll be 7,300,000 divided by 114,000. If you enter this into your calculator, you should get a rounded answer, but we're always going to round up to the nearest whole person because we're not going to say, oh, there's 0.3 of a person living there. We're going to count everyone as a whole person, so we always round up to the nearest whole person, always. So therefore, we have 64 people per mile squared within Arizona. That means that for every square mile, you should find around 64 people. Now, that isn't always the case because, of course, there is some wilderness in Arizona, and there's typically no one living in the wilderness unless you have like hermits or something. But more often than not, there's going to be 64 people per square mile. We're going to compare that to Phoenix, which has a population of 1.6 million, and its area is 517 square miles. So we do the same thing here. 1,600,000 divided by 517. When you enter that into your calculator, you'll be left with 3,094 people per mile squared. Now, this is much heavier. There's a lot more people within that amount, within that square mile. And that makes sense because Phoenix is much more urban than, say, a northern Arizona town, which is much smaller. And, of course, urban areas are going to have more people there, so therefore they're going to be more population dense. And that's because of a variety of reasons. It could be because jobs, it could be because location, access to transportation, various things that people use within cities. And that's typically why people move there, because they can find more jobs or it's more secure for them or whatever the case may be. And I can definitely speak truth to this because having grown up in a small town in Arizona, it's very easy just to go out in the woods and not see anyone at all. But if you try and do that down in Phoenix, it's going to be much more difficult. If I leave my apartment right now, I'm probably going to run into at least 10 people before I even reach the outside of my complex. So that's the big difference between really urban areas and really rural areas is just the amount of people that you would see. But granted, if I did like the amount of deer in Payson's area or something like that, you would see very, very similar numbers because there are a ton of animals up there as well. So again, it depends on what you're looking for and what you're studying as well for these. All right, guys, so thank you so much for watching this today. If you guys have any questions, please let me know, but have a great rest of your day. Take care.